Welcome to the final part of our First Steps video series, where we make a simple 2D platformer with Godot. In this video, we will add sound to our game, add a main menu with options, switch scenes, and do a little polishing up as we go along. Feel free to use the timestamps to jump around the video as needed. First, let's add some sounds. I have an audio folder here that has the sounds we will use. The links will be in the description. Let's drag the folder into the file system to import it into the project. Now, let's create an empty node, call it Sound Manager, and add an empty script to it. Then right-click on it and select Access as Unique Name. Let's also save the Sound Manager in a separate scene. We will be making the changes to the Sound Manager scene we just created. Let's add a jump sound to the player. To do this, we will use an audio stream player node. So let's add one as a child of the Sound Manager node and rename it to Jump Sound. Next, we can drag the jump sound into the stream field in the inspector. Then we go to the Sound Manager script and get a reference to the jump sound and make a new function called Play Jump Sound. In this function, we will just play the jump sound. And at the point where we press the jump button, we can also play the jump sound from the Sound Manager. Now when we play the game, we can see that when the player jumps, the jump sound is also played. Now let's add the hurt sound. We just repeat the process and add another audio stream player, call it hurt sound, and drag the hurt sound into the stream field in the inspector. In the Sound Manager script, we add a new function called Play Hurt Sound. And in the player script, where the player takes damage, we can remove the print function and call the Play Hurt Sound function from the Sound Manager script. Now taking another look at the way the player takes damage, it seems a little unfair that the player can take 2 hits in quick succession. So let's fix that. We will add some invincibility frames. And also, let's make the player flash red when she gets hit, to give us some visual feedback as well. To do this is really simple. All we need to do is disable the hazard trigger for a short time and then enable it when the player is teleported back to the last checkpoint. Let's rename the collision shape 2D to Hazard Call and get a reference to it in the script. Then, where the player collides with the hazard, we can disable the collision shape by calling Set Deferred and setting Disabled to True. And when the player is teleported to the last checkpoint, enable the collision shape by setting Disabled to False. Now when we play the game, we can see that the player only takes 1 hit, even if she is hit 2 times when falling into the pit. To change the color of the player, we will need access to the self-modulate value of the player sprite. So since we already have a reference to the player sprite in the script, at the point in the script where the player gets hit, we can change the self-modulate color to red and then back to white when the player is teleported back to the checkpoint. Okay, now that I've been playing the game for a while, I think that we should add a sound to the enemy to make it easier to have some feedback when the enemy is about to jump. I got a free whoosh sound off pixabay.com, so let's add it to our enemy. To do this, we can add another audio stream player in the Sound Manager, as before, and call it Enemy Sound, and drag the enemy sound into the stream field in the inspector. Now this time, we will go to the max polyphony settings and set it to 2. What this does is allow the node to play a maximum of 2 sounds, and then when this is reached, the oldest sound will be cut off. The idea here is to allow multiple sounds to play at once. I'm not actually sure how this works, but if someone watching knows, please share in the comments. Now we go to the enemy script and play the sound when the enemy jumps. I showed in greater detail how we set up the enemy in part 3 of the series. but let's quickly review. We set a variable jump velocity of -1400, set the gravity from the project settings, then got a reference to the timer node we created, which was set to autostart. In the physics process function, we check if the enemy is not on the floor and apply gravity to it. This will cause the enemy to fall to the floor. We connected an on-timer timeout signal to the script and checked if the enemy is on the floor, and then applied the jump velocity to the enemy, and then restarted the timer. Now to add the sound to the enemy, I would only like to add the sound if the player is within a certain distance from the enemy. Otherwise, there'll be too many sounds playing at once, which could be quite confusing. So first, we get a reference to the sound manager, and then a reference to the player, and set a variable for the enemy distance, which will be the distance from the player that we will play the sound. I did some testing and found that a distance of 400 pixels worked well for me. We check if the player's position is less than the enemy distance when the enemy jumps, then we play the sound. Now when we test the game, we see that the enemy sound is only played when the player gets less than the enemy distance, which was set to 400 pixels. And the last sound I would like to add is the level music. I would also like the music to loop. So, select the music file in the file system and go to the Import tab and check the loop checkbox, and then re-import. Then we add another audio stream player as a child of the sound manager and call it level music. Add the level music to the stream in the inspector. We could just select autoplay and that would start the music when the game starts. But let's get a reference to it in our script and add a function called play level music and call it in the onReady function. Now that we've added all of our sounds, now would be a good time to go through and adjust the volume of each sound so that they do not compete with each other. We can do this by selecting each sound and adjusting the volume slider until we are happy with the way it sounds. Oh, I almost forgot. Let's add a game over sound. You know what? Why not pause the video and see if you remember how it's done. Okay, did you get it? Let's move on. I will use this game over sound I got from opengameart.org. First, we add an audio stream player as a child of the sound manager. Rename it to Game Over Sound and drag the Game Over sound into the stream field in the inspector. Then we get a reference to the Game Over sound and create a function to play the Game Over sound. Then, at the point in the game where we handle the Game Over, we can call the Play Game Over function. If you got that, then you're right so far. But in this game, we will have to do a little more. And we can do some refactoring of our code as well. You see in the player script, where we handle calling the game over, we also call the pause game function. So let's move this line of code here and handle pausing the game inside of the game over function. Then, in the sound manager script, we create a function that will stop the level music, called stop level music. And since the game will be paused, we will need to set the process mode of this node to always, so that it will be able to carry out this function when the game is paused. Then, in the game manager script, we call the stop level music function. And now when we play the game, we can see that all the sounds work as intended. The level music is playing, the jump sound, enemy sound and herd sounds are working, and when it's game over, the level music stops and the game over music plays. Now let's add a simple main menu. First we add a new scene, and this time let's add a user interface node. This adds a control node to the tree. We rename it to main menu. Next we add a VBox container node and set its anchor position to bottom right. Then we add a button node and rename the button to start. In the inspector, we add the text to the button, and in the overrides we can change the font size. Duplicate the button 2 times using Ctrl+D. Then we rename the buttons to Options and Quit. Change the text in the inspector and reposition the VBox container to fit nicely on the screen. Now let's save the scene in a new folder called UI Scenes to keep things organized. When we play the game, we can see that the main menu has been created, but this looks a bit boring, so let's spice it up a little. I will add an animation 2D node, create a new animation and add the thumbnails of all the videos we did so far to the animation, and adjust the animation frames so that it plays at a reasonable speed. You may have noticed that our buttons have disappeared. So to fix this, we just drag the animated sprite over the VBox container in the scene tree, and the buttons will now show above the animation sprite 2D. Then I will add an audio source node and drag the level music into the stream field in the inspector. There's one thing I forgot to do. We'll need to go back to the animated sprite 2D node and click the autoplay animation button, so that the animation will automatically play when the scene starts. Now we just add a script to the main menu node and begin to edit the code. We can drag the main menu music into the script while holding the Control key to create a reference to it. In the ready function, we play the main menu music. And now if we play the current scene, we see that we have a more interesting main menu. There's a cool animation and we have the level music playing. But the buttons still don't work, so let's fix that now. We will use signals to connect and unpress signals to the script for each of the buttons and begin to construct our code. The quit button is the easiest. We just get the tree and call the quit function. And for the start button, we just get the tree and call change scene to file and pass the location of the level 1. We can just click and drag it without holding the Control key and release this time round. We will leave the options empty for now since we don't have an options menu. Before we test the game, we need to set the main menu as the main scene. So to do that, we go to Project, Project Settings, Application, Run, and set the main menu as the main scene. Now when we play the game, we see that if we click the quit button, the game exits, and if we click the start button, level 1 starts. Now let's make an options menu. First, add a new scene and add a user interface node as we did before. We will rename it to Options Menu. Now we add a button and change its anchor presets to the center of the screen. And call it back button and change its text to back and its font size to 30. This button will take us back to the main menu. Now a cool option would be to add a volume slider. So let's add that. We add a label node as a child of the options menu and call it volume label. Add the text in the text field in the inspector and change its font size. Then change its anchor presets to the center and reposition it under the back button. Then we add an H slider as a child of the label node and change its scale to 3 and reposition it under the label node. Now let's add a script to the options menu and connect an unpressed signal to the script for the back button. And as before, we can just use change scene to file and change the scene back to the main menu. Now let's add an audio source node, rename it and drag the level music into the stream field in the inspector. First, let's get a reference to the options music, and in the ready function, call play on the options music. With the H slider selected, connect an on-value change signal to the script. Then we make a variable called master volume and set it by finding the audio bus and getting the index using getBusIndex. We will be using the master bus in this case. You could call this variable anything you like, but since we are going to be controlling the master, I decided to call it master volume. Then, in the signal we created, we can change the volume in decibels of the audio bus by getting the audio signal and using setBusVolume dB. This takes two parameters: the audio bus that we want to change, in this case the master volume, and the second parameter is a value. In this case, we'll be setting it to the value of the slider. We can use if-else statements to mute the audio if the slider is at a certain value. So, we can say, if the slider is at a value of -10, then we can mute the audio by using setMuteBus, which also takes two parameters: the bus index, which in this case is the master volume, and a bool, which we will set to true. In the else, we set the bus mute to false. Now back in the scene with the H slider node selected, if you cannot see the slider bar, simply adjust the size of the slider by clicking on the select mode and dragging the handles out to the size that you like. Now in the inspector, we can set the minimum value to -10 and the maximum value to something like 2. And for the value, we can set it to -5. These values will depend on the audio you use, so feel free to play around with these values until you find something you like. Before we test this out, let's do 3 things. First, let's save the scene. Then, go back to the main menu, and now that we have the options scene, let's connect it to the options button. All we need to do is copy this line of code here and paste it in the options button signal, and change the options scene. And lastly, we can go back to the sound manager, and remember we had manually changed the volume of the level music in the inspector. Well, we'll need to make sure that the volume of the main menu and the options menu are the same as the game in order for this to work correctly. Now, when we play the game, we can see that we have a functioning options menu that can change the volume of the sound in the game. You can use this method combined with the method in part 3 of this series, where I showed you how to set up audio buses to make sliders that control all the sounds in the game. And with that, we're almost done. Remember in part 1 of the series, the object of the game was to find the mushroom and bring it back to Joe? Well, now that Jane has the mushroom, let's close the game loop by making a button that will return the player back to the main menu. In the level scene, if we go to the canvas layer and show the dialog box tree, which is the final message in the game, we can show the button that we had created previously and use this button to take us back to the main menu. To do this is really easy. We can rename the button to Win Button and add a script to the button as before, and set an on-press signal to the Win Button script. In the signal, we just change the scene to the main scene as we did before in the options menu. Now let's hide the scene and test the game. We can see that when the player returned the mushroom to Joe, the game is paused, and if the close button is clicked, the player is returned to the main menu, closing the game loop. Now we could stop here, but I want to do a few more final steps. In keeping with the current UI controls, let's make it so that the player can navigate the menu using the arrow keys. Also, add the player left and right movement to the A and D keys. And lastly, complete the game by hitting the Enter key to go back to the main menu. First, the menu buttons. Godot makes it really easy to use the arrow keys to navigate the menu. Let's go back to the options script and grab a reference to the Start button. Then, in the Ready function, we use StartButton.grabFocus. In the options script, we get a reference to the back button, and in the ready function we use backButton.grabFocus. When we play the game, we see that the start button on the main menu is selected when the game is started, and we can use the arrow keys to highlight the buttons and the enter key to select it. And we can also use the arrow keys to change the value of the slider. Now let's add the A and D keys to the player movement. We simply go to the project, project settings, and input map. And for the right input, we click on the plus button and press the D key. Then, click on the plus button for the left input and press the A key. Now when we play the game, we can control the player using the A and D keys as well as the arrow keys. And finally, let's make it so that we can end the game using the enter key. To do this, we need to create a new input event called close and set the input to the enter key. Then, with the win button selected, in the inspector we create a new shortcut and add element. Click on the drop down and add a new input event action. Then, click on it and add the close event that we just created, making sure to spell it exactly as we did in the input map. Now, so that we don't confuse the player, we can change the text on the win button to enter. And there you have it, the game is complete. You have all the skills you need to make your first platformer. Don't be afraid to experiment and have fun. You could add a sound when you highlight the buttons, or create more levels and add them to a game. If you want to add more levels, just create the level, and at the point where you close the game loop, just change the scene to the new level, instead of the main menu. And that's it for another video. Thanks for watching. If you liked the video, give it a like, and subscribe if you'd like to join me in the game lab right here on Dragu Games.